Hello and welcome to our channel where we explore the world of Odoo. In this video, we'll walk you through the process of creating your very own AI-powered custom dashboard app. Don't worry, it's not as hard as it sounds, and if you're a beginner, this is the perfect video to learn many things about Odoo module development. To implement the custom dashboard, we'll be creating an app named Quickboard App. A Quickboard is an app that allows users to create their own data visualization using single value cards, simple charts, and two-column lists. A single value card is an item on the Quickboard that display a single value from an aggregation of a field from an Odoo model. This means users need to choose which model, which field for the value, and an aggregation function. Chart items is an item on Quickboard that display data in a chart. So, in addition of model, field, and aggregation function, a chart also requires additional field for the dimension. Two-column lists are lists that display data dimension on the first column and values on the second column. The Quickboard is flexible enough for user to arrange the items however they want. In other words, users can move around and resize items on the Quickboard. It also provides a kind of automatic item arrangement, and of course it can use AI to generate the items. This time we're going to use several additional components. Gridstack.js to facilitate flexible layout system. Spin.js to display a throbber when loading data. Chart.js for the charts. LM Studio for AI backend. Qwen 2.5 Coder 7v, Instruct for the AI model. And Autogen for the AI framework. Please find the link for these components in the video description. Also, please don't forget that Odoo already bundled with Chart.js, so you don't need to download it again. Before diving into the code, let's take a moment to understand how the Quickboard module works. This will provide you with a clear picture of the overall architecture and help you better grasp the purpose of each component. When a user accesses the Quickboard items are loaded and passed to Gridstack.js. As each item is rendered, it requests its respective data. While waiting for the data to be fetched, the item displays a throbber using Spin.js to indicate that the data is being loaded. Once the data is available, each item is rendered according to its type. For single value cards, we create a custom component with a simple template. Since they only need to display a single value, the template remains straightforward and easy to understand. When dealing with chart items, we again create a custom component, but this time utilizing Chart.js. This library provides a wide range of options for creating visually appealing charts and graphs, but for simplicity, this time we only use charts that require simple data format: the bar chart, line chart, pie chart, donut chart, and polar area chart. For displaying data in a two-column list format, we use a standard HTML table. The table is populated with the fetched data, making it easy to read and understand. Once the initial setup is complete, the Quickboard is ready for user interaction. To add a new Quickboard item, a form view is shown to ask the user for the item's definition. After capturing the user's input, the Quickboard is reloaded to display the newly added item. To save the Quickboard layout, Gridstack.js serialization features are utilized to get the position and size of each item. This information is then saved to the respective item's record for persistence. To perform automatic item arrangement, the compact function built into Gridstack.js is triggered. This feature rearranges the items on the Quickboard to optimize their layout. To ask AI to generate Quickboard items, a wizard dialog is shown to the user. This dialog prompts the user to specify which models the AI should use to generate the items. I will explain more about the AI in the second part of this video. For now, we need to create the Quickboard first. As always, first we need to create the directory for the module, the manifest file, the init files, and the initial directory structure such as directory for controllers, models, security, views, and wizard, as well as the static directory. Before we continue to the codes, now is the perfect time to decide how to include the Gridstack.js and the Spin.js into the module. Odoo can load external JavaScript libraries hosted on other server or placed locally. I chose the later for this project. By convention, external libraries needs to be placed to the directory lib under static directory. Next, we create the model for Quickboard items. Since the differences between item types are not too many, let's just use one model for all of them. And since we decided to use just one model, we need to add several input validations. For example, we only require dimensions for charts and lists. Don't forget to add this model to the models directory init file. We also need to define access right for the new model. And since we require user to access ir.model and ir.model.field, it's better to create a new group for the app. We call this new group QuickBoard user. And while we're at it, we might as well make QuickBoard users to only have access to their own QuickBoard items. We do this by creating a new record rule and set the domain_force parameter. Once the new group is created, we can then use the new group in the security file. We continue by creating new views for the QuickBoard item and menus. The list view for this class is very straightforward. We don't actually need to show the list view because the items will be shown on the QuickBoard anyway. But it's useful if something went wrong with the QuickBoard and we need to debug the module. For the form view, we need to add all the fields except the ones for position and size. And since we use one model for all item types, we set required and invisible attributes according to the item's type. And we also create the action and the menu for these views. In order to use our new security group effectively, we also need to specify the group's attribute on the menus. This way, the menu won't be visible if the user is not in the group. Then we continue with creating an HTTP controller to provide API for the front-end codes. We create a method to retrieve QuickBoard items attributes, with an option to also retrieve its data from a period of time. Fortunately, every Odoo model already has a method called readGroup. This method groups data and apply aggregation function to it just like we want it. So to retrieve a QuickBoard items data, we simply build parameters for method readGroup and pass it on. For basic items, we directly apply the chosen field name for value and the aggregation function along with the dates filter to the readGroup method and return the result. For chart items and list items, we add dimension and granularity if the dimension is a date or datetime field. And we also set the ordering and limit parameter for the list items. To make the front-end development easier, we also add a sequence for data. This is useful for debugging and for using the data with loops. We then use this method to create one API to retrieve the just one item information with data and one API to retrieve all items without data. And lastly, we create an API to save the position and size of every QuickBoard items. Next, we create the front-end code. To display the QuickBoard, we don't use the usual Odoo's built-in view components. We use our own components instead. First, we need to create the menu and action to access the QuickBoard component. And since we're using our own component, instead of using window action, we use client action and set the tag attribute to our component name. We also use lazy loader. This way Odoo only load our components when user actually click the menu. We need to register the lazy loader with the same string as the value for the tag parameter of the client action and use the QuickBoard component as the parameter for the lazy loader component. Before we continue to QuickBoard component codes, let's create a supporting service that calls the API we created earlier. Back to the QuickBoard component, as mentioned earlier, we first load the item's position and size. Then we pass the information to Gridstack.js. I'll explain the other processes on this component first, since they're pretty straightforward. After that, I'll explain the process of loading items data and rendering it. As mentioned before, to save the QuickBoard layout, we simply use Gridstack.js serialization feature. We call Gridstack.js compact function to arrange the items automatically. And to add a new item, we show the QuickBoard item form view in a dialog using window action. We also add a function to apply the date filters. For now, we leave the function to generate QuickBoard items using AI empty. We'll get into that later. And since by default Chart.js display empty chart if there's no data fetched into it, we add a function to set up the Chart.js to display a string no data to display instead of an empty chart. And finally, we register the QuickBoard component to lazy component registry. To display the QuickBoard properly, we need to create a template which defines the user interface elements of it. On the template, we define buttons, the input elements for date filter, and the QuickBoard items. As shown here, the button's onClick event is linked to the respective QuickBoard function. For the QuickBoard items, we use another custom component in a for each loop. Now, let's talk about the QuickBoard items. For the QuickBoard items, we create a dynamic custom component which will select the actual component based on the item type. As mentioned earlier, we have 3 kind of quick board items. By using dynamic component and separating each type of the items into different components, our codes are cleaner and easier to maintain. Next, we create a base component for these items since they share similar properties and behavior. To request data from server, we define a quick board service as a property. And we define 2 common functions on the base item component, a function to get the default throbber settings and a function to show quick board items form view in a dialog. For the single value card, we create a new component named QuickBoard Item Basic. Upon rendering, the item shows the throbber and requests data from Odoo server by using the QuickBoard service. We also add a formatting function for the value. The template for the basic items is pretty straightforward. Most of it is for visual structure and styling. As we can see here, we use background color and text color property of the QuickBoard item as the style for a div element. And we use the icon, the value, and the title property of the item in span elements. To implement the chart items, we create similar component to the basic items, but we add a step to pass the data to Chart.js. In this step, we build the chart parameters based on the chart type property of the item. The template for the chart item is very simple since everything is handled by the Chart.js. We only need to provide canvas element. The rest is for the title and icon property of the item. The component for list items is also very similar with the basic item. We only add properties related to the dimension of the item's data. On the template for the list items, we use simple HTML table and populate the rows with for each loop. The rest is similar to the chart item template. At this point, the QuickBoard part of the module is nearly finished. We need to add 2 more things: to reload items when users modify or edit them, and to set the default size and position of new items. To facilitate the reloading function, we're going to use Odoo bus library by adding our own bus channel. On the QuickBoard item model, we need to import dictionary and list class from typing library and override model's web save method. We add code to send item updated notification to the bus on our channel. On the JavaScript side, we add code to add our channel, subscribe to the channel, and add handler function for the messages from the channel. We create our channel on the QuickBoard component. This way the channel is created before any other QuickBoard component is created. We add the code to subscribe the channel to the base channel, so we don't have to subscribe it on the child items, and add empty message handler function. On the basic item component, we override the base item message handler function to hide the content temporarily and show the throbber while loading data. And we do this for the chart item component and the list item component too. To set the default position and size, we override the create method of the models class. We set the position to be on a new row each time an item is created. This way we don't have to worry about the new item changing our current layout. Imagine if you have created many items and has already arranged them neatly, but then you add a new item and then the layout is ruined.
No, we don't want that.
Now, let's see if it works. Before we continue to the AI part, I'd really love it if you could help by clicking that subscribe button below. Your support means everything, and I appreciate your likes and shares as well. Without further ado, let's jump to the AI part. As mentioned in the beginning of this video, we're going to use LM Studio with Qwen 2.5 Coder, 7b, Instruct, and Autogen. Let's take a moment to see how it works. When user want to ask AI to generate the clipboard items, we ask user to specify which models the AI should be working on, and whether the item size and position should also be arranged by AI or without AI. Based on these inputs, we build a prompt with the model details and pass it to the AI. Unfortunately, as with any AI-generated content, there's no guarantee of perfection every time. Therefore, validation is crucial. If the AI's response meets our criteria, we proceed to create the suggested items. However, if the response is deemed invalid, we request the AI to make corrections until either a valid answer is provided or the AI has attempted to fix the issue certain number of times without success. In such cases, we inform the user that the AI failed to generate the items as requested. If the user chooses to ask AI to perform the items arrangement, we build a different prompt specifically for the items arrangement. The same treatment then applied to this process. We validate the answer until a valid answer is generated or a certain number of unsuccessful attempts has been made. If user opts not to use AI for the item arrangement, we put the basic items on the first rows and arrange the rest of the items after these rows. Now, let's jump into the code. First, we create a new wizard as mentioned earlier. We only ask which model the AI should work on and whether the AI should also arrange the item placement or not. If the user confirms to generate the items, the wizard passes the parameters to AI and wait for the result. If the generated result is deemed valid, we perform additional validation. To make the wizard usable, we need to add it to the wizard directory init file and give access to Clipboard user group. And we also need to add it to the modules manifest file. We then add the code to show the generation wizard to the onClick event handler that we left empty previously. We continue by extending Autogen with a new proxy agent to validate JSON. The sole purpose of this agent is to validate JSON against a JSON schema. Therefore, we need to create a JSON schema for the clipboard item. The JSON schema contains the fields and the rules that the JSON object must follow. For example, the field types, the required fields, and we can also define conditional rules. In our case, we define three schemas: the full schema, data-only schema, and layout schema. The full schema is for the final validation, which we use on the wizard. The data-only schema is used to validate the item generated by the AI. The layout schema is used to validate the AI item arrangement. And finally, we create a new class to wire all AI-related things up. Since the code is rather long and very similar with the previous videos where we also use Autogen, I'll only explain the main points of the code. Let's take a look at the method that is used by the wizard to trigger the whole generation process. The method generateQuickboard contains the code, which implements the process explained earlier. First, we prepare the parameters, which will be used later in the process: the model name, model fields, and JSON schema for the model. Then we create AI agents, which will perform the generation as well as the validation of the generated items. After that, we build the message or prompt for the AI and start the process. If the AI generate a valid JSON, we continue with the item arrangement. Upon successful arrangement, we return the result to the wizard. Similar steps is performed when asking the AI to arrange the items. We create the agents, build the prompt, and pass it to the AI and validate the result. In terms of steps, both tasks are similar. The main differences lies on the prompt and the JSON schema used. While the programming and the making of the JSON schema is not very difficult, the main challenge here is to create prompt that works with our setup. Let's take a look to the item generation prompts. The system prompt is rather long because we need to give the AI details information about what we want. First, we define the role for the AI, then we provide information or context for the conversation, then we give example and rules. While this prompt works, unfortunately, when I apply the same format for the item placement, the AI tends to use the example as is. That's why I removed the example section for the item placement. Now, as the final touch, let's add an icon to make our module look nicer on the app list. And we're all set. Let's see if it works. But first we need to run LM Studio and load the model before we use the Quickboard app. A quick note before we end this video. Although it's far from perfect, with this video we've explored the possibility to use AI to generate simple dashboard items and to arrange the items. While using generative AI always carries some kind of randomness which might not be desirable, fortunately, there are many techniques to improve and minimize unexpected results such as RAG, guided generation, structured output, etc. If you're interested to develop dashboard app using generative AI, I would suggest to try these techniques for better results. And if you're planning to experiment with this module, let us know in the comment below. Thank you for watching, and don't forget to like and share this video and subscribe to my channel so you can stay up to date on my experiments and tutorials.